Well, good morning or good afternoon, everybody. I'm going to give you very basic notes on energy just to get your mindset going for the energy research. So let's see, energy research and project. I like to say and project because second semester we'll be doing and project. So you kind of need to think ahead a little bit about what do you want to build in the second semester that's going to be an energy conversion or capturing device. And then this semester, you want to base your research on that. And you might change your mind in the next week or so, but we'll get it started here. So to begin with, energy is the ability to cause change. Let me zoom in on here. So energy is the ability to cause change. The ability to cause change. And if you like, we can even say, you can add on there, to make something move. You don't have to put that in, but and that movement can be on a level that we can see, like pushing a car across the room. It could be in a place we can detect but not see, like heat. Or it could be in something we can't see but can measure, like radio waves transmitted from one place to another. So let's see. I'm going to abbreviate energy, and I recommend you do for these notes, just as a capital E. It'll make it easier. Energy can be stored. Oh, let me change the color here. Oh, purple, I like that. Energy can be stored. And we'll call that potential energy. Potential energy, which we'll tend to abbreviate PE. It's just storing energy. There are several ways that can happen. We'll go over that. Energy can be transferred is the next one. Okay, so energy can be transferred, which kind of implies you're moving it. Transfer is some type of a moving. And that we call kinetic energy. I'll put that in parentheses. Kinetic from the old Latin word kinin, which means to move. K-I-N-E-T-I-C. Kinetic energy. Usually in chemistry, we'll be measuring kinetic energy by measuring heat. Abbreviation will be KE. Right? One of the notes we had before about matter, we said matter, atoms cannot be created nor destroyed. Energy cannot be created nor destroyed either. Energy cannot, I don't know, is that one word or two? Cannot be created nor destroyed. Energy cannot be created nor destroyed. Einstein has this very famous relativity equation. Relativity equation. What is E equal to? You all know this.
MC squared.
E equals MC squared. So that just stands for energy. The M in there just stands for matter. Or we can even just say mass, something that we've measured. And then there's a conversion factor. C is a constant. It's a conversion factor. And you're used to conversion factors. Now, I'm going to put an example here. You don't need to do this. You know that, for example, the circumference of a circle is equal to 2 pi. Is that correct? Did I get the right equation there? Circumference is equal to 2 pi? I think that's, okay, good. So, oh, wait a minute. 2 pi times what?
2 pi r squared.
Times the radius. Isn't it 2 pi r? I knew I was leaving something off. So if you know the radius of a circle, you can multiply it by 2 and then by pi. Pi is a conversion factor. Pi is a conversion factor that lets you convert a radius into something else on a circle, either area or circumference. And that's all that this c is in c squared. It turns out that the c in there actually turns out to be the same as the speed of light, but that's another story on there. What it means is you can take matter and you can convert it into energy. That's what nuclear power is. You're taking some matter in the form of radioactive uranium or plutonium, and it is going to change, it's going to break down, decay, and in the process, it will release some energy. And then, so you can convert energy and matter back and forth, but you can't destroy it. Okay, I've gone on too long there. So let's come over and label this over here kinetic energy. K-I-N-E, kinetic energy. You can abbreviate just K-E if you like. This will be potential energy. So let's see. Kinetic energy, examples would be moving objects. Which happens because of a push or a pull. That's getting back to your 8th grade physics. Heat is also a type of kinetic energy. We call it thermal to be more fancy, but heat and thermal, and that's moving, vibrating molecules. It's just vibrating molecules. So you're not going to see the molecules moving necessarily, but they can be vibrating, and we measure that as heat. There can be waves, like light waves, or even radio waves, all sorts of waves. We can have sound waves here that we're familiar with since we have an atmosphere to deal with. That's just air molecules bouncing into each other, and then that transmits energy to us. And then we've got like water waves. And you got the waves on the beach going up and down, so with that. And then I think the last one here we'll say is electricity. And electricity is moving electrons. So when you start thinking about what project you're going to do, your device that you're going to use is either going to change or capture or store energy in one of these types. Under potential energy, I'd like you to let's put chemical. Chemical potential energy, CPE for short. And that's storing energy in bonds. Storing energy in chemical bonds. Whether it's ionic, covalent, metallic. And let's see, there's another type you're going to come across, which is kind of related to this. Elastic, we're almost done. Elastic potential energy. That's when matter wants to keep its shape, or molecules want to keep their arrangement. I'm just going to say matter keeps its shape. It's shorter to write. Matter wants to keep its shape. And the best example is a rubber band. Because of the way the molecules are arranged in there, you pull this apart, it wants to go back to this shape. And some things, if you squeeze them, they want to come back to their shape. I don't have anything squeezable here. So that's elastic potential energy. And last one we're going to do, thank you for your attention, is gravitational potential energy. That's the ability of something that can fall. Gravitational potential energy. GPE. That's the ability of something to fall. Ability of something to fall. So if I pick up a great big toolbox and hold it over somebody's head, okay, they might be a little leery because, I'm going to do this in case it does fall, they might be a little leery because they know there's the potential that thing could fall if my arm fails here. So there's a lot of energy stored right here holding up this, there we go, that's my toolbox there I was holding over a student's head. There's a lot of potential for that to fall, and that's called gravitational potential energy. So, looking to your research report, then we're going to get out of this class. So the research report. I want you to have an intro. Sorry about that. You need to have the main body with supporting facts. And you're going to have your summary conclusion. I hope this is something similar to what you might be doing in your English classes. I didn't get this figured out till I was in college. I was not a great English student in high school. So, when we go to the library, what I want you to do is, I want you first off, we're not going to the computer labs, we're going to get on the computers. I need you to first off figure out, what do you think you might want to build? And I'm going to have it link you to a document over there. In fact, I'm going to stop this now. Let me stop this one because we're done with that. I don't need to do any more there. Stop.